On 2nd December 2016, my team of 8 students went to Budiman Inspection headquarters at Taman Kajang Utama Kajang. There we managed to find out their history and the services of NDT offered. Budiman Inspection Sdn Berhad was founded in 2006 by an experienced management team from the quality check sector with many years experience in both offshore and onshore industries, from power plants and refineries to offshore platforms and jackets. They began with the rental NDT equipment in Malaysia. They also supply the inspection services and recognize the need to provide their clients with quality support in the form of specialist personnel from engineering sectors, in particular the QA and QC disciplines. This enabled their clients to man up larger projects without the financial risk associated with long-term employment contracts. Budiman Inspection offered the following NDT services, but not limited to: positive material identification (PMI), ultrasonic testing, radiography testing, magnetic particle testing, dye penetrant testing, and many more of the non-destructive testing. In this video, we will elaborate and focus on the 3 techniques among many others. Firstly, I would like to touch on dye penetrant testing. The technique of dye penetrant testing is based on the ability of a liquid to be drawn into a clean surface, breaking flaw by capillary action. After a period of penetration time, excess surface penetrant is removed and a developer is applied. This draws the penetrant from the flaw to reveal its presence. Color contrast: penetrant requires good white light, while fluorescents need to be used in darkened conditions with an ultraviolet light, also known as black light. Secondly, phase array ultrasonic testing. It is an advanced ultrasonic method which can reveal defects embedded in the material that cannot be easily resolved with conventional ultrasonic testing. Lastly, I will touch on radiographic testing, which it provides a permanent record in the form of a radiograph and provides a highly sensitive image of the internal structure of the material. This method is based on the same principle as medical radiography at the hospital. A piece of radiographic film is placed on the remote side of a material under inspection, and radiation is then transmitted from one side to the other where the radiographic film is placed. My friends will later elaborate more on this all 3 testing.
Dye penetrant inspection, also called liquid penetrant inspection or penetrant testing, is a widely applied and low-cost inspection method used to locate subsurface breaking defects in all non-porous material, such as metal, plastic, or ceramics. The penetrant may be applied to all materials, although for ferrous components, magnetic particle inspection is often used instead for its subsurface deflection capability. LPI is used to detect casting, forging, or welding surface defects such as hairline cracks, surface porosity, leaks in new products, and fatigue cracks on its in-service components. DPI is based upon capillary action, where low surface tension fluid penetrates into clean and dry surface breaking discontinuities. Penetrant may be applied to test the component by dipping, spraying, or brushing. After adequate penetrant time has been allowed, the excess penetrant is removed and a developer is applied. The developer helps to draw penetrant out of the flaw so that an invisible indication becomes visible to the inspector. Inspection is performed under ultraviolet or white light, depending on the type of dye used, fluorescent or non-fluorescent dye.
Step in liquid penetrant testing. The first step is to clean the dirt, grease, or any loose scale that could either keep the penetrant out of a defect or cause fault indication. The cleaning methods may include solvents, alkaline cleaning steps, or media blasting. The second step is to apply the penetrant to the surface of the item being tested. The penetrant is allowed dwell time to soak into any flaws, which is generally 5 to 30 minutes. The third step is to remove the excess penetrant, and the removal method is controlled by the type of the penetrant used. The fourth step is, after the excess penetrant has been removed, a white developer is applied to the sample. Several developer types are available, including dry powder, water suspendable, and water soluble. And Next, the inspector will use the visible light with suitable intensity for visible dye penetrant, the ultraviolet radiation of adequate intensity along with the low ambient light levels for the fluorescent penetrant examination. The inspection of the test surface should take place after 10 to 30 minute development time, depends of the product kind. And lastly, the test surface is often cleaned after the inspection and recording of the defect, especially if the post-inspection coating processes are scheduled.
The main advantages of dye penetrant testing are the speed of the test and the low cost. Disadvantages include the detection of the only surface flaws, skin irritation, and the inspection should be on smooth, clean surface where excessive penetrant can be removed prior to being developed. Conducting the test on rough surface, such as welded welds, will make it difficult to remove any excessive penetrant and could result in false indications. Water washable penetrant should be considered here if there is no other option is available. Also, on certain surface, a great enough color contrast cannot be achieved or dye will stain on the workpiece. Limited training is required for the operator, although experience is quite valuable. Proper cleaning is necessary to assure that the surface contaminants have been removed and any defects present are clean and dry. Some cleaning methods have been shown to detrimental to the test sensitivity, so acid etching to remove metal smearing and reopen the defect may be necessary. Budiman Inspection prefers ultrasonic testing over dye penetrant testing since it has more disadvantages over advantages.
For ultrasonic testing may vary according to the cases involved. However, there are 9 steps applied for this case. First, surface preparation. The base metal on each side of the weld shall be free from foreign matters that might interfere with the examination. Number 2, scanning sensitivity. The scanning shall be performed at a gain setting at least 2 times the primary reference level, whereas evaluation shall be performed with respect to the primary reference level, which are based on angle beam or straight beam method. Number 3, detection of defects parallel to the weld. The angle beam shall be directed at approximately right angle to the weld axis from 2 directions where possible. The search unit shall be manipulated so that the ultrasonic beam passes through the required volumes of weld and adjacent base metal. Detection of transverse defect. The angle beam shall be directed angular to the weld axis. The search unit shall be manipulated so that the ultrasonic beam passes through the all of volume be examined. Number 5, method of sizing indications. For normal and angle beam ultrasonic testing inspection, method of sizing indication is half value method measurement. Number 6, direction and extent of scanning. Direction of scanning in ultrasonic testing inspection of weld line angle beam shall be perpendicular to the weld line axis, and extended of related scanning shall be cover the full scape area and 100% of weld line. Number 7, method for discriminating geometric from flow indication. Linear indications such as cracks, lacks of penetration, lack of fusion, and slack line produce single very short and high flow indication that when search units swing around the defect's location, it causes immediate drop of related echo in ultrasonic testing display device. Rounded indications such as isolated porosity and slack produce single line low gain flow indication that when search units swing around the defect's location, it relates echo in ultrasonic testing display device not eliminate immediately. False and non-relevant indication shall be separated by relevant indication with interpretation of the depth, location, height of related echo by expert ultrasonic testing operator. Number 8, weld configuration to be examined. The applicable thickness dimension for ultrasonic testing inspection in this project is above 10 mm. Base material product for this project is plate and pipe form. Last but not least is scanning method. The scanning method for this procedure is manual with a scan method. And disadvantage of the ultrasonic testing.
Advantage of ultrasonic testing is high penetrating power, and then high sensitivity permitting and detection of extremely small flaws, and then in many cases only one surface need to be accessible. Number 4 is greater accuracy than other non-destructive method in determining the depth of internal flaws and thickness of the part with the parallel surface. Then some capability of estimating the size, orientation, shape, and the nature of defects. Next will be some capability of estimation the structure of alloy and of component. And then the last one of advantage in ultrasonic testing is non-hazardous to operation or to nearby the personnel and has no effect on equipment material of the victimility. Of ultrasonic testing. First is manual operation require careful attention by experienced technician. Then intensive technical knowledge is required for the development of the inspection procedures. Number 3 is parts that are rough, irregular in shape, very small or thin or not homogeneous are difficult to inspect. So number 4 is surface must be prepared by cleaning and removing loose scale paint. Then the couplers are needed to provide effective transfer of ultrasonic wave energy between transducer and part are being inspected unless a non-contact technique is used. Then inspected item must be water resistant when using water-based couples that do not contain rust inhibitor.
One of the alternative methods used by the company is a radiographic image testing. X-ray films for general radiography consist of an emulsion gelatin containing radiation-sensitive silver halide crystals, such as silver bromide or silver chloride, that is flexible and transparent and blue-tinted base. The emulsion is different from those used in other types of photography films to account for the distinct characteristics of gamma rays and X-rays, but X-rays films are sensitive to light. Usually the emulsion is coated on both sides of the base in layers about 0.5 milli-inch thick. Putting emulsion on both sides of the base doubles the amount of radiation-sensitive silver halide and thus increase the film speed. The emulsion layers are thin enough so that the developing, fixing, and drying can be accomplished in a reasonable time. A few of the films used for the radiography only have emulsion on one side, which produces the greatest detail in the image. This change is such a small nature that it cannot be detected by any ordinary physical methods that is called latent hidden image. However, the exposed grains are now more sensitive to the reduction process when exposed to a chemical solution that is a developer, and the reaction results in the formation of black metallic silver. It is the silver suspended to the gelatin on both sides of the base that creates an image.
In conclusion, we were able to understand on why phase array ultrasonic testing is the favorite testing of Budiman Inspection. It is mainly because power advantages overshadow all the other advantages of the other two testings.
The visit has taught us the application of non-destructive testing in real engineering world.
It has given us precious insights on the fundamental and principles needed to achieve in order to deliver the top-notch performance, particularly in dye penetration testing, radiography testing, and UV testing.
Budiman Inspection has been gracefully kind in sharing these useful and amazing experiences with us. This knowledge would prepare us more for the career world that awaits us later.
Not to forget special thanks to Professor Aziz for his guidance and wisdom throughout this semester and has given us this valuable opportunity for us to explore.
We thank you all for watching. Please remember to give us a thumbs up and subscribe down below. Thank you all again for watching.